Scientists claim that the Earth is inexorably moving towards a new ice age, possibly much harsher than the previous ones. But what if the cosmic clock measuring these cycles has broken, and it's our fault? Today, we will delve into the frightening facts that reveal the mystery of these rhythms and cast doubt on our future. After all, calculations show that the ice could start advancing soon. And perhaps this process has already been secretly initiated. We are accustomed to climate stability, but this is just a brief moment in the drama of Earth's history. Our planet constantly experiences eras of monstrous cold and scorching heat. Imagine Earth bound by ice a mile thick, oceans frozen, but land turned into an icy desert with temperatures at the equator below 0 Fahrenheit. This is how the planet looked during the Cryogenian period, about 750 million years ago, resembling a giant ice ball for almost 100 million years. And then the ice retreated, giving way to eras of tropical forests in Antarctica. These giant climate swings occurred long before humans. The last glacial period, the Valdai glaciation, ended just 12,000 years ago. Glaciers 1.5 to 2 miles thick covered half the world. The sea level was 400 feet lower. Britain was connected to Europe, Asia to America. The climate was colder and drier, but life thrived in the tundra steppes, where woolly mammoths and rhinoceroses, bison, and horses grazed. Our ancestors hunted them, surviving in this harsh world. What governs these grand cycles? Why does the Earth periodically freeze? The answer lies in space, in the barely noticeable dance of our planet. For a long time, humanity did not know the past of its planet. The theory of the Earth's slow cooling prevailed. The discovery of remains of warm-loving organisms in the north only reinforced this belief. But geology was accumulating facts that did not fit into this picture. Giant boulders thousands of miles from mountains grew on rocks, mixed-up rock formations. All of this demanded an explanation. The explanation came in 1837 from the Swiss scientist Louis Agassiz. The Earth experienced periods of great glaciations. Glaciers, similar to those in the Alps, once covered vast areas, moved, and retreated, leaving traces. The idea of a glacier in the place of Paris seemed absurd, but the facts were stubborn. The key to the mechanism of the cycles was found by the Serbian mathematician Milutin Milankovitch in the early 20th century. His element was celestial mechanics. In an era of upheaval, he dedicated his life to calculating the smallest changes in Earth's orbit and the tilt of its axis over hundreds of thousands of years, doing everything manually, without computers. His theory, the Milankovitch cycles, asserts that ice ages are the natural result of long-period changes in Earth's movement. Our planet undergoes 3 barely noticeable but critically important oscillations. They change the amount of sunlight reaching different latitudes at different times, acting like a cosmic metronome for global cooling and warming. Milankovitch calculated these cycles, and his predictions remarkably matched the data later obtained from ice cores and marine sediments. His work provided us with the tool for understanding past climates and predicting future climate changes. Let's consider the first 2 celestial rhythms of Milankovitch. The orbit of our planet is not a perfect circle. It slowly changes shape over about 100,000 years, oscillating between nearly circular and slightly elongated, elliptical. This change is called eccentricity. When the orbit is more elongated, the Earth is farther from the Sun at certain times, altering the intensity of the seasons. If the farthest point of the orbit, the aphelion, occurs during the summer in the northern hemisphere, it becomes cooler. Such a summer is not capable of melting all the snow that fell during the winter in the high latitudes. The snow accumulates, turns into ice, forming ice sheets. This 100,000-year cycle aligns well with the rhythm of major glaciations over the last million years. The second factor is the tilt of the Earth's axis. The planet's axis of rotation is tilted relative to the orbital plane, currently at about 23.5 degrees. This tilt gives us the change of seasons. But it also oscillates over a 41,000-year cycle, roughly from 22 to 24.5 degrees. The greater the tilt angle, the more contrasting the seasons. Summer is hotter, winter is colder. A hot summer contributes to the melting of ice. When the tilt angle decreases, seasonal differences are smoothed out. Summer becomes cooler, winter milder. This again creates conditions for ice accumulation. A cool summer prevents the snow from melting. Milankovitch considered this cycle crucial, although now the dominant seems to be the 100,000-year eccentricity cycle. Nevertheless, the influence of the axial tilt is undeniable. These 2 celestial movements, eccentricity and axial tilt, create a complex melody of Earth's climate, defining the ages of ice and warmth. The third Milankovitch cycle is precession, the slow wobble of Earth's axis, similar to the wobbling of a spinning top. The axis is not just tilted, but it also slowly describes a cone in space. A full rotation of this cone takes about 26,000 years. How does this affect us? Precession changes the orientation of the axis relative to the points of the orbit: perihelion, the closest to the Sun, and aphelion, the farthest. Currently, summer in the northern hemisphere occurs at aphelion, and winter at perihelion. This slightly moderates our seasons, but in 13,000 years, the situation will change. Summer will be at perihelion, and winter at aphelion. Seasonal contrasts will become much more pronounced. Combined with the slow rotation of Earth's elliptical orbit itself, the full cycle of a season coinciding with a specific point in the orbit takes on average about 23,000 years. How is this related to ice? When precession makes summer in the northern hemisphere cool, for example, it occurs at aphelion, snow melts less effectively. If this coincides with a small axial tilt, ice accumulates and glaciers grow. When precession makes summer hot, it promotes ice melting and the onset of an interglacial period. Precession acts as a fine-tuner of the climate. It redistributes heat across seasons and hemispheres, strengthening or weakening conditions for glacier growth. This slow dance of Earth's axis completes the picture of celestial influences on the ice ages of our planet. A full rotation of this cone takes about 26,000 years. Milankovich's theory was confirmed by the silent witnesses of the past: ice cores and seabed sediments. Scientists have learned to read the climate record encoded in these archives. In the ice cores extracted from miles deep, each layer holds information about the temperature and atmospheric composition of the past. The analysis of seabed sediments, especially the shells of microorganisms, also allowed for the reconstruction of temperature and ice volume. When scientists compared these data with Milankovich's calculations, the match was astonishing. Climate fluctuations clearly followed the rhythms of eccentricity, axial tilt, and precession. The theory became a fact. Let's move 20,000 years back. Back in the midst of the last ice age, ice sheets up to 1.5 to 2 miles thick covered North America and Eurasia. The sea level dropped by almost 400 feet, exposing land bridges, such as between Asia and America. The climate was significantly colder and drier, but life thrived in the tundra steppe, a vast ocean of grass from Europe to Alaska. There roamed woolly mammoths, rhinoceroses, steppe bison, and wild horses. They were hunted by cave lions and our ancestors. This world was born and destroyed by the great Milankovitch cycles. The Milankovitch cycles set the rhythm, but the ice age itself is triggered by earthly factors and feedback loops that amplify the weak signal from space. The main amplifier is the albedo effect. Snow and ice reflect more sunlight, light than the dark surface. When the snow accumulates due to the cool summer, the area of the white surface increases. More light is reflected, less heat is absorbed, leading to further cooling and even more ice accumulation. This is a self-sustaining process. The second player is greenhouse gases, primarily carbon dioxide. Their concentration changes, and a decrease in their amount weakens the greenhouse effect, causing the planet to cool. The reduction of carbon dioxide was characteristic of all past glacial periods. The third mechanism is related to ocean currents. The global conveyor transports heat from the equator to the poles. A key element, the AMOC, is sensitive to the salinity of the water. The melting of glaciers and the influx of fresh water can disrupt or stop the circulation, causing a sharp regional cooling, as during the Younger Dryas. Finally, catastrophic triggers are possible. Powerful volcanic eruptions can block sunlight. The impact of large asteroids could theoretically cause tsunamis, dust emissions, and alter ocean chemistry, pushing the climate towards freezing. The onset of an ice age is a complex process, where orbital cycles set the stage and terrestrial mechanisms implement them. If we look at Earth on a geological time scale, we will see that right now, following the Milankovitch cycles, it should be preparing for cooling. The cosmic conductor is already giving signals. Two key factors indicate this. First, the tilt of the Earth's axis. It is decreasing, having reached its maximum about 10,000 years ago, and is moving towards a minimum, which will be reached in about 10,000 years. The decrease in tilt smooths out the seasons, making summers in high latitudes cooler. And a cool summer is the main ally of ice, preventing the melting of winter. Snow. The natural course of events should have already initiated the slow accumulation of ice. Secondly, and this is particularly concerning, there is a slowdown in the Atlantic, meridional overturning circulation, AMOC. This system of ocean currents, like a giant heat pump, transfers heat from the tropics to the north, moderating the climate of Europe and North America. Studies show that the AMOC is weakening, possibly due to the influx of fresh water from melting Greenland glaciers. There are concerns that the system is approaching a tipping point of collapse. If this happens, temperatures in the North Atlantic could plummet by many degrees Fahrenheit. Over decades, plunging the region into conditions of a mini ice age. Period. So, natural cycles in the state of the ocean signal. The time of warmth is coming to an end. But something strange is happening, disrupting this ancient order. For the first time in Earth's history, an external force has interfered with its climate mechanisms we ourselves. By burning fossil fuels. Since the Industrial Revolution, we have released trillions of tons into the atmosphere of carbon dioxide, pressing the gas pedal of the climate system. The numbers speak for themselves. The concentration of carbon dioxide is now about 420 parts per million. This is the highest level in millions of years. During the last glacial maximum, it was only 180 parts per million. Even in the warm interglacial periods of the past, it did not exceed 300. We have created a new atmospheric reality. How does this break the cycles? Ice ages begin when orbital factors make the summer cool, but now the atmosphere is oversaturated with greenhouse gases, trapping heat like a thick blanket. Even when the Milankovitch cycles tell the planet to cool down, the summer remains too warm. Snow melts, ice doesn't accumulate. We have effectively turned off the natural thermostat. Where does this lead? Research shows we have likely already postponed the next ice age by tens of thousands of years, and possibly forever. Sounds good? But the problem is that we have crudely broken the natural cycle without knowing the consequences. Are we delaying the cold or creating conditions for uncontrolled overheating and climate chaos? We are playing with forces that we have barely begun to understand. What if our intervention not only postponed but permanently broke the mechanism of glacial cycles? What if we have shifted the planet into a new state from which there is no return to the familiar rhythms? This is not just a hypothesis, but a conclusion that scientists are leaning towards. We have changed the fundamental parameters of the climate system. Look at the ice caps of Greenland and Antarctica, relics of past glaciations, stabilizing the climate. Previously, they remained stable, ready to grow again. Now they are deteriorating at a catastrophic rate, losing hundreds of billions of tons of ice annually. Science speaks of points of no return. If the global temperature rises above a certain threshold, perhaps just 2.5 or 3.5 degrees Fahrenheit above pre-industrial levels, the melting of the ice sheets will become irreversible. It will continue for centuries until they completely disappear. And this means a rise in sea levels by tens of feet. The complete melting of Greenland will add about 23 feet, and West Antarctica another 10 to 13, submerging coastal cities and entire countries under water. This is a real possibility. Moreover, it could lead to Earth becoming a hothouse planet, a world without ice. At the poles, with much higher sea levels, and a different, possibly hostile climate for us. By canceling the ice age, we risk not achieving eternal summer, but rather plunging the planet into an alien geological era. If the Milankovitch cycles no longer govern the climate, what will replace them? Instead of smooth transitions between ice and warmth, we risk ending up with a world of climate fever, abrupt, chaotic, and extreme fluctuations. Disruption of the energy balance, melting ice, and weakening ocean currents create conditions for unpredictable shifts. Models show a future not of stable warming, but a series of destructive extreme events. These could be mega droughts turning fertile lands into deserts, superstorms of unprecedented strength, fueled by an overheated ocean, abnormal heat waves, where the human body cannot survive without cooling, heat that scorches crops. But chaos doesn't only mean heat. Disruption of atmospheric and ocean circulation can also lead to sudden deep cold spells in certain regions. Sharp intrusions of Arctic air, abnormal snowfalls, devastating frosts. The climate is becoming nervous, unpredictable. Previously, ice ages were a regulator. Now it is broken. We have let the climate genie out of the bottle. We are entering an era of climate chaos, created by us. Survival will require a completely different level of adaptation. What if global warming is capable of triggering a return to cold? But not a slow one, rather a sharp and catastrophic one? It's a paradox, but it is seriously considered by scientists. The main suspect is again the AMOC, the Atlantic Meridional overturning. Circulation. Its weakening due to glacier melting could lead to a complete collapse, possibly even within this century. If this happens, the northern hemisphere will face the effect of the heating being turned off. Temperatures in northern Europe and the eastern part of North America could drop by dozens of degrees Fahrenheit. Within a few years, winters would become incredibly harsh, summers short and cool. This is not a full-fledged ice age, but a sharp regional cooling lasting for centuries. Imagine London or New York. In the climate of Siberia, agriculture would collapse. The demand for energy for heating would increase manifold. Transportation routes could be frozen over. This is a scenario reminiscent of the movie The Day After Tomorrow or the game Frostpunk, with mass migrations and social upheavals. Such a sharp cooling caused by the disruption of the system due to warming is different from natural cycles. It is unpredictable and strikes the most developed regions. The specter of cold can return like a sudden invader, born of our recklessness. The realization of the climate's unpredictability presents humanity with a serious challenge. Do we have the knowledge, technology, resources, and will to prepare and adapt? On one hand, we have technologies, energy-efficient buildings, climate-resistant crop varieties, water desalination, renewable energy. Theoretically, we could create protected agro-complexes, build dams, develop early warning systems. Geoengineering is even being discussed, although its risks are unclear. On the other hand, the problems are colossal. The scale of the task is enormous. Trillions of dollars and infrastructure restructuring are required. Unprecedented international cooperation is necessary, which is currently lacking. Political disagreements and inequality hinder progress. There is a huge inertia in both climate systems and our social structures. Even if emissions stop, warming will continue for decades. Our ancestors survived the Ice Age thanks to ingenuity and mobility. We have created a complex but fragile global civilization, dependent on stability. Our strength is also our vulnerability. Can we demonstrate the wisdom of our ancestors? The window of opportunity for preparation is closing. We have journeyed through ice ages and cosmic rhythms. We have witnessed the Earth's dance, governed by Milankovitch cycles, shaping the face of the planet. We have glimpsed the world of mammoths and understood the mechanisms of glaciations. And we are confronted with the reality. Our species has gained the power to break these ancient cycles. Where are we now? Do we remain subject to the cosmic clock, which will eventually strike the hour of cold? Or have we irreversibly changed the rules, creating a new chaotic climate reality? There is no definitive answer. We see signals of natural cooling and a slowdown of the ocean conveyor. But at the same time, we see unprecedented levels of greenhouse gases trapping heat and melting glaciers, threatening to raise sea levels. Which force will prevail? Will nature take its course, plunging us into a new glacial cycle? Or have we passed the point of no return to an overheated greenhouse planet? Or perhaps we are headed for a path of instability, where extreme fluctuations become the norm? For the first time, a species possesses the knowledge to understand global cycles and the power to disrupt them. The future is not predetermined. It depends on our choices in the coming decades. The fate of civilization is being decided now. Do we have the wisdom and will to make the right choice? The answer lies beyond the horizon.